So we are going to solve a problem in which we have a k rotated array and we have to perform a searching in that array to find a target element. So the original array, for example, is this, and a k rotated array or a k rotated array are 3 4 5 1 2, which is rotated by k is equals to 2. It's basically a rotation. So this problem can be solved by brute force approach and a better approach. By brute force we will get an O of n, which is not a better time complexity, and the second approach will be an O of log n, which will be a better than O of n. So O of n can be performed simply by for loop, by going from n by going to n elements in an array and just comparing it with the target element and returning that index, then it's done. But for finding a better approach like log n, O log n, then we have to perform a binary search. For doing a binary search in this type of problem, we have to do it in two steps, in which first step is to find a pivot point. What is a pivot point? So pivot point will be a point where if an array is been rotated, then we have to find the original index from which the array is been rotated. Like for example 3 4 5 1 and 2, like rotation, first rotation, like original array rotation, we have to find this, where the first element of the array, like from where the rotation has begun, and we have to find that index, for which we can simply do is find a pivot point. If the high is we have to compare the mid. Simply we have to compare a mid value of that element with the high. If it's greater, then the pivot point is towards the right, and low is equals to mid plus 1, else it is to the left, then high is equals to mid. At the end, the low point means when we have crossed the condition where low is less than high, then the loop will end and the end point will be the pivot point, means the low. And second binary search, what we'll do is perform the original binary search, but with a twist, where the real mid, because as we know that the array has been rotated, therefore we have to find the real mid. So real mid value will be, first we have to find a mid which is equal to basically low plus high divided by 2, originally you know that, and the real mid will be mid plus pivot point modulo n, because if it's greater, then we have to lower down, because we will get an runtime error on that. And then perform the original binary search by just doing the and comparing with the target of the real mid. If it's lower, then search towards the left, like high is equals to mid minus 1, and if it's greater than the mid, then find towards the right, like low is equals to mid plus 1. And at the end, if you do not find an element in that, just return -1, but you will find an element, because the question itself satisfy or says that there is an element present, the target element. So yeah, this is the solution. At the end I will attach the C++ solution.